you for stopping by and welcome to the show. I'm your host, Nathan Patnam, and today we're going to be talking about stacks and how to implement them in Python. So what exactly is a stack? A stack is a data structure where the first thing that's added to it is the last thing out. And so what you see in front of you is a couple stacks of lunch trays. And the reason why I put them there is just to give a little bit of a story behind stacks, what stacks are. So at the university that I go to in our cafeteria, we have lunch trays that we can put our dirty dishes on and put on a nearby conveyor belt so that the cafeteria staff can clean it. And so if I wanted to get a tray at the very bottom of the stack, such as right here, I would have to remove every tray above it to get to it. And so the oldest tray is at the bottom and the newer trays are at the top, which still reemphasizes this idea of a stack where the first thing I added to it, aka the oldest thing, will be the last thing to come out since it's at the very bottom. So in addition to this, what exactly can a stack do? So there's a couple of operations. So one is empty. That will return a Boolean value, either true or false, depending on if there's things in the stack or not. Peek will return the thing that's at the very top of the stack. Pop will return the thing that's at the very top of the stack and also remove it from the stack as well. And so with peek and pop, these are both going to be order 1 time complexity. And then in addition to that, with pushing is how we add things to our stack. And this will take an item and add it to the top of the stack and push everything else down on top of it. With peek and pop, the only contingent thing is that there has to be stuff in the stack, otherwise an error will be thrown, since you can't really see an empty stack and you can't really remove something from an empty stack. And then size will return the current size of the stack. So now let's visualize the process of how exactly a stack will work. And I wrote some Python code on the right. And so this, for example, in our function main, all we're doing is instantiating the stack class. And so what you see here is just one box, which represents some place in your memory where there's just this container that we call a stack that there's currently nothing in. And so a question that I have is, what exactly are the values if these two methods or these two operations that we just saw were to be called? So in the first case is empty, it will return true since there's nothing really in the stack. In our second case, what's the size of it? It's 0 because, as I said again, there's nothing really in the stack. So say, for example, we use push to add something to it. Now we can see that there's something in our stack data structure, and this is 3 right here. Let's say, for example, we pushed again, and we can see that 3 is now at the bottom of the stack, and 6 is at the top of the stack. And this is the idea of a stack where the first thing that we added, this 3 from before, is at the very bottom, and the newer things are at the top. And so what, for example, what do you think the value would be, or what value would we get if we would call the peek method? And then the answer to this is 6, since peek would just return 6, which is at the very top of the stack. Now, for example, now it's just to show the same idea again. If we had, and we use push, and we added 4 to the top of the stack, it would push 6 and 3 down. And if we were to do peek again, we would get 4 this time. And then now let's talk about pop. So what pop does is it removes the thing on top of the stack and also returns it. And so in this case, if we did our stack.pop, we would get back the 4 because that was on top of the stack, and we would remove it from the stack as well. And so what is the value? Our stack is empty, and the size methods now. So if we use this empty, we would obviously get false in this case, since there's stuff in the stack. And if we use size, we would get 2, since there's 2 things left over. So now let's implement our stack in Python. So the first thing I'm going to do is slide over to my code editor. For my IDE, I'm using Visual Studio Code, and no, I'm not endorsed by them in any way. I just like the IDE. And so the first thing I'm going to do is write some unit tests. And so if there's some concepts in this video like unit tests or big O notation that you aren't familiar with, or maybe you've only heard a couple times and want to know more about it, just let me know in the comments. I can create more videos about this content so I can cover more and more aspects of the computer science discipline. So now when we go to our unit tests, I'm just going to go and cover this just a little bit. So the first thing we're going to do in setup is create our stack. And then the first unit test is checking to see that when I created this stack, it's empty, so there's nothing in it. The second unit test is making sure that I can add stuff to it. So I'm going to add something to it and then check to make sure that the thing I added to it would be the thing I would get if I were to peek, since there's only one item in it, the thing on top. So my third test is to remove items. So the conventional methodology besides unit test is that every unit test you only really have like 1 assert equals or 1 assert statement. So in this case, I felt in order to really show the remove item aspect of it, I'm going to first show that I'm going to first add 3 items to it. Then I'm going to first check to make sure that the item on the top is 9, or the thing that we added last to it. Then I'm going to remove it and make sure I get 9 back, since pop also removes the value as well as returning it to the user. And then I'm going to peek again because the new top of the stack should be 4. And the last unit test we're going to do is we're just going to check the size of it. So we're going to add 3 things to it, and then we're going to make sure that when we call the size of method, we're going to get 3 back since there's 3 items in it. So like any good way of doing some development or test-driven development, in this case with unit tests, we're going to make sure that all our unit tests fail. Since if you look at our stack class, all we really have is just placeholder passes. We just have the operations lined in, and we really have no logic in place. So if I just ran my unit test, I see that all 4 of them failed since they're trying to call methods that really haven't been created. So now let's go over to the stack class, and let's go and code this up. So the first thing I'm going to do is write class stack, which is the conventional Python notation of creating a stack class or creating a class in general. And then now I'm going to create a constructor. So I can create a video about constructors, but the general premise behind a constructor is this is the method that creates the actual object. And it'll be called when you do something like whenever you create the objects. In our case, when we do something like this, where we take the name of the class and we instantiate it by putting parentheses around it, and this will call the constructor. And so there should be really only 2 class variables we keep track of with our stack. One will be how we store the data. And so for our stack class in Python, we'll be implementing a list. And then we'll be also using a variable to keep track of the size of it. And so because just as a pre-warner, and you can comment below if you want to implement this using in a different language like Java where you have to worry about management. Since I'm implementing this in a list, I'm not going to have to worry about extending it out if I don't pre-allocate enough memory in place. And so basically what I'm saying here is that in some languages, I have to tell how big of a stack I want before I start using it. But in Python, the way that we're doing it, we're going to make it dynamic so I can keep adding to it and not having to worry about it. And I can write the code with both cases if you want me to. Like I said, again, comment below. So the first thing I'm going to do is create a variable to keep track of the items in our stack. And in this case, since we're using a list, we'll be implementing it with a list. And then the second item that we'll, second class variable we'll have is size. And we'll instantiate that to 0 since when I first create an item, there'll be really nothing in it. And so now let's finish the isEmpty method. And so basically the idea behind it is that isEmpty should return true if the size of the stack is 0 and should return false in any case else because that means other stuff in the stack. So the easiest way we can do this is just return, and then we can write a conditional here and say self.size equals 0. And so this will see if the self.size is 0. If it is, it'll return true, which means it's empty, and if it's not, it's false. So now let's go back to our unit tests, and we can see that we finished the empty method. So now let's test it again. So we had 1 failure and 3 errors. So now when we test it again, we just have 3 errors, and the reason why we're getting these errors is because we haven't really implemented the methods that are being called here. And that 1 failure that we saw before, that was from the test stack created, is not being it's not failing anymore. We can look and see that out of the 3 tests, that's not one of them test stack created. So now let's go and move on. So what peek does is that it will look at the top of a stack and it'll return the item in it. And so the only contingent thing that we need in our peek is that there has to be stuff in our stack. And so we're going to assume that the user, who in my case is me, would make sure that I'll be using peek after I add stuff to it. And so all we have to do with peek is just return the thing that's currently at the top of our stack. And so in terms of implementation, we'll return the last thing in the list. So all we'll do is we'll take our thing that's storing our items, and we'll just return what's at the very end of it. So self.size, which will keep track of how many items are in it, -1. And the reason that we're using -1 is because Python has 0-based indexing. And so, for example, say, for example, I had an empty stack, and then I added 1 item to it. The size would be 1. But if I were to say self.items 1, so in this case, say, for example, my stack was that. If I were to do something like return stack of 1, I would get an out of bounds exception since this would be going past the index, which is why I'm subtracting 1. So that's the peek method. So the pop method is basically like the peek method, but we're also going to be removing the data point as well from the stack. So we can do, since we're using a list, we can return self.items.pop. and that will just remove it from the list as well. Push, all we're doing in our case is just appending it. So since we're using a list, all we have to do is just add to the end of it. So we can say self.items.append. And another thing I have to add is that when we're pushing something on top of a stack, we're going to be adding a value to it. So we'll say item. And so item represents what I want to push on the stack, so like 6, 4, or 9 in our cases with this unit test. And so now I'm just going to append to the list whatever I'm passing in. And then size, the easiest way to do this is just return what our self.size point is. And so there's a couple things that I need to do. I need to update the size when I'm popping something. So I'll do, whenever I'm removing something from a stack, I subtract 1 from the size. And then whenever I'm adding something to the stack, I can just increment the size. And then in order to get the size, all I have to do is something like just return the size, since I'll keep track of whatever I need to. So let's run the unit test again, and we have all 4 of them passing. So this is the main works of how to implement this. If you want me to implement this in a language where I have to worry about data structures that are not dynamic, in our case lists, and we have to worry about arrays, I can do that also. And that's basically it in terms of stacks and how to implement them in Python. Thanks again for tuning in, and next time we'll be talking about queues.